All right, it's recording. So exercise 1F. 1F is now inverse functions. Inverse functions in the exam, there's only one thing they're really testing. And the test is, for a function to have an inverse function, it must first be A. Does anyone know what that first skill they're testing? It needs to be a one-to-one. So keyword, function. Function can only be one-to-one or a many-to-one. But in order for you to have an inverse function, it must be a one-to-one. And just on a quick side, if you didn't understand why it has to be a one-to-one, think about a many-to-one function. A quadratic graph is a many-to-one function, right? So it looks like that. But if you did a reflection, y equals x, so all the x becomes the y's, y becomes the x, which actually is a reflection. It looks like this. So pretend there's a mirror here. Your graph ends up looking like this. Now that red line, what type of relation is this? Yeah. This now is for one x, you get many y's. So this is now a one to many, and it's not function. Whereas the question was asking if you want an inverse function. Sometimes they say inverse relation. So if they say inverse relation, that's okay. Nothing wrong. But if they say inverse function, a many-to-one won't even end up with a function when you do the flip. And then a way to remember it is you can see a one-to-one. So remember how I told you it was 1x to 1y? If you swap it, if you do the inverse, you're essentially saying y equals x and x equals y. Then the inverse becomes now yx, and it still is a one-to-one. Because if you swap the ones, you swap the y's across and the x becomes this, it's still a one-to-one, so it's still a function. But in a many-to-one, yes, that is a function, starts off as a function, but when you do the inverse and you swap them around, it ends up being a one-to-many. But once you have many for the y values, that becomes the inverse. And that becomes an inverse relation, not a function. Okay, so you can see why only a one-to-one where you swap the x and y's, that it's still a function. Many-to-one, even though it's a function, doesn't end up being a function here. So hence, function comes relation. That's why the one skill that they're first testing is to see if you know, has to be a one-to-one function for you to have an inverse function. Okay? All right. Other than that, what are other properties that you must know? So you know it's a one-to-one function to have an inverse function. Well, then when you swap the x and y's, these are the notations that you can write. So you can write f inverse of x, or the inverse function, let it equal to y. So that's the y coordinates. Or you can say swapping the x and y, you're essentially saying x now becomes y, and the y becomes the x. That's essentially what you're saying here. So that bit there, you're saying for every xy coordinate, it now becomes yx. And that's why we replace that x with a y, and we replace that y with an x. And this is what this notation means, reflection. Okay, so if you wanted to say, do an inverse function, this is the notation you would write. Okay? Properties. If you swap the x and y's, that also means the domain of your original function ends up being the range of the inverse, because it swaps around. And same thing, the domain of your inverse is technically the range of your original function. That box there is essentially all they're testing at the end of the year. They obviously give you different functions, different ways of asking the questions. It could be a multiple choice or a short answer question. But those are the three key points they're testing if you understand. First one's usually multiple choice. Okay, so whether it's a one-to-one function or not. All right, let's do some examples. Here we go. Example 1 from your textbook, or exercise 1F, question 2D. Here we go. So you've got a function notation. Says function f, domain is all real numbers. Function, you got 3x minus 2 all over 4. What type of function is 3x minus 2 over 4? Can I please have, let's go with Leo. What do you think this is? It's a linear graph. Okay, so if you really just break it up apart, it becomes 3/4 x minus 2 over 4, which really is the same thing as saying 3 over 4x minus half. Okay, so you can think of it as mx plus c there, which ironically or interestingly enough, it's right up here too. Okay, so I know the gradient's 3/4, it's a positive gradient, and has a y-intercept at -half. So here, the notation again, if I say let y equal to the inverse function, then when you want to find the inverse function, you're swapping the x and y, so that's what that's saying there, for the function. So here we go. So then f of y equals x for the function. Find the rule for the inverse. Okay, so f of y equals x for the inverse function, if you want to say function there. So here we go, writing it in. So f of y becomes now, you got 3y minus 2 over 4 because we're doing f of y. So y gets substituted in here. So f of y becomes 3y minus 2 on 4 equals x. If you rearrange that to make y the subject, then that is your inverse function. But can you see the notation I'm using to set it out? So here we go. This now becomes 3y minus 2 is equal to 4x. Add 2 on both sides. Here we go. That's minus 2. Add 2 on both sides. Here we go. And then to get rid of the 3, divide both sides by 3. And there is my inverse function. Okay, so just for those who aren't keeping up with my algebra here, I just said times 4 times 4. 4's cancel out. Add 2, add 2. Negative 2 cancels out. Divide 3, divide 3. And because there are 2 terms, you have to divide every term by 3. Which I'm assuming your algebra at this point can pick up that. Okay? Do you leave your answer like this? Don't. If the question in your exam asks for this, they usually say define. If they say define, don't leave it like this. Define means this, using function notation. And usually you can tell because it'll be 2 marks. Why is it 2 marks? Because they're looking for a restricted domain to make it a 1-to-1. And then you've got your actual inverse function. So you get 1 mark for the steps that I'm just doing just now, and then your correct definition. Okay, so if they say define. If they say rule, I also still do it this way, unless they just say, what's the inverse function? Then I can write that. Okay, but usually in the exam, start writing this and look at the marks. The marks normally indicate whether you leave it in function notation or whether you just leave this. And then the next question, they'll say, find the domain. Okay, or state the domain of the inverse. Then that's 1 plus 1. Okay. So here we go. I would usually then write the inverse function. So defining it, so f inverse or -1, colon, the domain. Well, the domain of the original function is r, but we already said that this is a linear function, so that means the range of this function is also r. So therefore, remember, range of your original function is equal to the domain of the inverse. So therefore, the domain of the inverse here should also be r. And that's simply because I can visualize that 3x minus 2 over 4 is a linear graph with range being all real values. Okay, so r maps onto r, comma, f inverse of x is then equal to 4/3 x plus 2/3. That's a 2 marker, usually. To get that one right, and then your method to get to the defining part. So if they say define the inverse function, I want you to start doing it this way. Okay, don't just leave it as that. You may lose marks. Okay? Okay, so, actually I already said it here. So if the question asks you to define, I had it set up already. Oh well, I went ahead of myself. There you go. So this bit was meant to go here. So far, so good. So that's exercise 1F. Okay, in a nutshell, you'll learn to sketch it. You have to know how to sketch inverses. And one of the tips is, I usually tell my students, if you struggle with, visualizing it, you can tilt your head diagonally and draw a symmetrical look, then it works. You know those pictures where they say something like this, and they say, fill in the missing side to make it symmetrical. So this is a vertical line, and I know that I'm missing that spot to make it symmetrical. Well, it's the same thing, but you tilt your head. If the graph was like this, and here's your y equals x line, tilt your head, and then you try to draw it just the same way, and you should be able to you tilt your head, you should be able to see it kind of looks like that. Okay, so that's one tip if you're needing to practice sketching inverse functions, but your exercise 1F should get you to train sketching inverses. So if you're not good at sketching inverses, that's an opportunity. This is literally just algebra, and this is just clarity. Okay, so how clear and accurate you are, that's what makes the difference here. In terms of theory, there's only three things that you need to show. Range of the original is the domain of the inverse. Domain of the original is the range of the inverse, and needs to be a one-to-one to have an inverse function. Okay? All right, let's flip over. Here we go. So for each of the following graphs, this is the example I was saying, to draw the inverse of each corresponding functions. Again, same thing. Since we know this is a 3 to 3, that means the line for y equals x literally crosses that point. So now if you tilt your head and you try to draw it symmetrically, then I can see that that means this side has to be symmetrical to that. So these two must be symmetrical. And then for it to be symmetrical to that, well, that. Does that make sense what I mean by tilting your head and looking at it symmetrically? So that's a practice that you can do for these type of questions. And that's in your exercise book, question 11. Okay, so if you need to practice on sketching, that's what you do for inverse functions. You can have a go with the C and F or in your own time. So again, I'm just going through the theory and what you need to know for 1F. And let's do this problem. So this is a typical one for an exam question, maybe multiple choice, sometimes in a short answer for the early questions, because it's considered easy. So here we go, question 13b. Let's have a look at this one. You've got a g function that has a domain of b to 2. So we know that it goes from some number up until 2. We just don't know where b is. So b can be negative or b can be positive. But we know that the g function is a quadratic. Now I've drawn it for you to visualize. Usually they don't. Usually they don't give you the graph, and it's your job to visualize that. Okay? So I'm saying it's a 1 minus x squared, so it's gone up by 1, inverse reflection because of that minus. If b is the smallest real number such that g has an inverse function, keyword, function. So not only is it an inverse, it has to be a function. Find b and g inverse, which means find the inverse rule, okay, and find the domain to make it work. What you can see here is what type of function is this, or what type of relation is g of x at the moment? Out of the four, you got one-to-one, many-to-one, one-to-many, and many-to-many. Many-to-one. This is a many-to-one because vertical line test says function. Great. Horizontal line says that crosses twice, so it has to be a many-to-one. So it crosses twice, it's a many-to-one. But a many-to-one is not going to have an inverse function. Because we said before, if you swap it around, x and y's, it becomes still one-to-many. So you need to change this graph now, or restrict the domain, so that you end up with a one-to-one. Because right now it's not a one-to-one. So where can you restrict it? What would b have to be in order for it to be the smallest real number in order for you to have a one-to-one? Because right now it's not a one-to-one. Leo? 0. Now why do you think 0? And how do you, what's the key? Horizontal line test, very good. And the key part was, I was trying to say, the turning point. Yeah, the turning point is going to be key because right up at that point, that's the maximum it gets to. So anything less than 0 then becomes a many-to-one. So that means if it's a turning point, you can either have this half, that's a one-to-one, or you can have this half is a one-to-one. So in the exam, if it's a multiple choice question, they might say which one of the correct, like they'll write the function notation and they'll say which domain is the correct inverse function. And you have to choose. Now they can say negative infinity up until 0 inclusive for this g of x, and you can have an inverse function. Or you can have from 0 all the way up until 2, and that would also be a one-to-one. So out of these two, based on my scenario, 2 is the upper end. That means b has to be 0. That's the smallest value you can get. Okay, you can have 1, you can have 2 as well, or you can have 0.5, but they said smallest. smallest real number. So the smallest real number you can have is 0. So therefore, just from seeing that, what's that defined? Then g of x must be a 1 to 1. So therefore, b must be 0. So the domain of g is equal to 0 to 2 at the moment. So that's the pink line that I'm colored here. Then the last bit is find g of inverse or g inverse. And like we did before, you can say let y equal to g inverse of x, then g of y equals x to find the inverse. So essentially your algebra here is you're just swapping the x and y's. Okay, so then it becomes x is equal to 1 minus y squared. Subtract 1 on both sides, you get x minus 1 is equal to negative y squared. Divide by negative on both sides, you get negative x plus 1 equals y squared. And then finally, square root both sides. But remember, when you square root both sides, what do you have to include? Plus minus, very good. So you got a plus and a minus, and you got negative x plus 1. What's the problem? It is well, technically it is a function, but together is a relation. That's true. So just going back, if you're not understanding what Leo's saying is if you sketch both the plus and the minus right now, you'll get the top square root and the bottom square root. There has to only be one answer because this is a relation. We said we want inverse function. Which one is the correct one? And how can you be guaranteed? How do you know? What are you looking for? Remember the 3 key things they're testing. What am I going to use to test this? Krish? Yeah. So the range, we said the range of the original function has to be the domain of the inverse, right? So if you think about this, if I asked you what is the range, if you had cut it from 0 to 2, the range is from negative 3 up until, what's that? 1. Oh, no, 0. No, what is that? Yeah. No. Is that 1, 0? Oh, sorry, it's this one. 0, 1. So from negative 3 to negative 3 up until 1, that's my range. That's the range of your original function, which is the domain of the inverse. But then what is the domain of the function? The domain of the function is the range of the inverse. In this case, we already know is from 0 to 2. So which one of these graphs, the positive version or the negative version, will you get a range of the inverse to be 0 to 2? Positive or negative? Positive. And that's how you know. Okay? Or, if you didn't even know that, another way to visualize it is, if you practice sketching the inverse, you can actually ignore this blue line and draw in that y equals x line and now try to do the symmetry. So if you had to do the symmetry right now, so it comes down here, so the symmetry, tilt your head, this will go this way, yeah? And then this part will go, well, this one's over here, so they will go, where is it? Oh, it should be like that, yeah, there we go. So it'll be like that, okay? So if you tilt it and you draw it, then you can tell, well, if it's going like this, is that the upper half or is it the bottom half? And you can kind of tell, yeah? So there's 2 ways to look at that. You can look at it at a theoretical point or an algebraic point, or you can look at it graphically. If you were to sketch the inverse of this, what would it look like? And if you can sketch the inverse, then you can visualize whether it's the upper half or the bottom half. Okay, but if you left your answer like this at the end of year, you definitely lose a mark for sure because they will test that bit, whether you know it's plus or minus. Now, I would have liked it to be a minus version because that's the one that students tend to do wrong, because when they square root, they often forget the plus minus. So they'll leave their answers as root negative x plus 1, but doesn't mean they understood that it was the positive. So usually the examiners will make sure it's the negative version so that when you square root, the kids who leave it like this means that they didn't know it was a plus or minus and they didn't know how to check which one is the correct one. So likely the examiners would make it a negative so that it shows you have to take that next step to prove it's that. Yeah, but in this example, it's a positive. Okay, so whether you realized it or not, you might have just got it by luck, or if you actually understood why it works, it was all in that keyword inverse function. So far, so good? Okay, so that's 1F. So I'm just trying to give you the essence of it. You'll take your time to practice. and learn that. But that's 1F. Yeah.
In the end, do we have to write it in function notation?
All the time. Every time. I would do, especially something like that. That could be a 2 to 3 mark because there's a justification point as well. Very likely, I would not gamble in the exam, but for my own sort of calculations, I probably wouldn't care. But when I'm in the exam, I'll probably do everything a bit more unnecessary than I need to in terms of detail, especially if it's like a 3 mark question. If it's 1 mark, I don't care. Just write your answer. Yeah. All right. Copy those notes if you like. Otherwise, you can watch the video again. But that is exercise 1F. All right, how am I doing for time? So 12:43. Cool, good. So the next one is a bit easier. You can use Desmos. If you've never used it before, we can play around with it together. But I'm just going to get you to explore. I don't want you to memorize these things unless you are happy memorizing. There's a whole bunch of polynomial graphs. Now, 1G and 7A are technically together. So by the time we get to chapter 7, I'm going to skip 7A because 7A and 1G is very similar to each other. Okay? So the 2 sheets I gave you, where is it? Just pause the video for this one.